Hello there. Today we're going to be taking a look at this. This is David Guesswin's MFM reader and emulator. This is a phenomenally complicated little device that can be both an MFM drive and an MFM controller because it can image MFM drives and then act as an emulator to pretend to be that drive after it has been imaged in a system. This makes it an extremely unique and powerful tool for working with older drives, but it's really difficult to use, not because it has been poorly designed, just because this stuff is pretty terrible. I said before in videos when working with MFM drives that the drives themselves are married to the controllers, and that's way more true than I even realized before I started today. So we're going to be looking at imaging some drives and some of the complications that can arise when doing that. We're also going to use this device to demonstrate using a solid state replacement for a 40-year-old hard drive. Now, before we get started, I'm going to let you know that I don't have a ton of seat time with this yet because it's really niche in its use cases because it is only for MFM hard drives, which I don't even have a ton of myself yet. So I'm still getting to grips with it, and because I don't have that many MFM drives to use with it, I'm going to have to rely on my first experiences here. Let's take a closer look at the hardware for the MFM reader emulator. It is an open source project, but the one I have here I bought from the Decromancer as a pre-made kit. I optioned it with the 5¼ inch bay mount and got the extra drive connection header as well. On the board, the main things you need to know about are the IDC headers that are used to connect the cables for imaging a drive and the card edge connectors that take the place of a drive when emulating one. The brain of this is a BeagleBone Black SBC Linux system. The Decromancer unit came preloaded with all of the software you need on Debian, but it's also available on GitHub. The device is configured entirely from Linux by logging into the computer remotely using SSH. My objectives for right now are going to be imaging and emulating the ST225 that came from the Nightmare 5160. It is back in the office. So let's go ahead and make some notes here. So one is going to be image ST225. The second objective is going to be imaging the ST412, but we're not going to be able to decode that, as you'll see. Actually, we will be able to decode the 412, but I didn't know that when filming this. We'll get back to that later in the video. Third, as a test of the ST225 data, we're going to actually be able to mount it in 86 box and boot it because we get a fully decoded image. So 86 box tests. After we validated that the decoded data works, we can use the emulator file that the MFM reader makes, and we can emulate the ST225 back in the original machine that I have over here. So that will be our final step, and that gives us a full circle of emulating, where we can take the original drive, make an image of it, digitize it, use it in an emulator, and then recreate the drive later if needed, all with one really powerful device. So I'm looking forward to going through all of those steps today. All right, let's get these all connected to utilize this thing. So the MFM reader emulator connects through Ethernet so that you can SSH into it because it is very Linuxy. And then we need to connect the drive to this. So MFM drives, and I'm going to leave the MFM drive on this pad here to isolate it from the table as I work. MFM drives need two cables. One of them is shared between multiple drives. So if you notice on here, there are two connectors because you can connect two drives to this at once. That is the shared data cable here. Go ahead and plug that in. Then we have the control cable for the individual drives. At least I'm pretty sure that's what those two cables are for. MFM is weird, and again, I don't have that much experience with it, but I believe that's what those are. So we need to connect both of those cables for the drive. Then we need power, and the MFM emulator uses a Molex 4-pin amp mate and lock technically connector for power, which makes sense because you can mount it inside a computer as a drive. So my Decromancer built unit here, I opted to get the 5¼ inch mount bay for, so this could go into a computer and act as a hard drive that way, and we'll try that in a little bit here. So I'm going to power that there, and then the drive here. And then that should be it, and ready to go to image this. I'm plugging this in here, but I have this all on a power strip, and I'll turn it all on in a moment. All right, I'm ready to fire it all up. I have a microphone connected here so you can hear the lovely sounds of the MFM drive spinning up. And once it's all booted, we'll go ahead and get an image here. All right, I'm going to SSH into the device now. The default username is Debian, and you'll have to find the IP address from your router if you're going that route. I have done a SSH copy ID over there already, so I don't have to type a password to log in. But with that, we are in there. Now, if we want to make an image, we need to run setup MFM read, which will configure the GPIO on the BeagleBone for this, and then we're ready to run an imaging command. Now, I've created a full read script here that just gives me some generic file names and gives me most of the options that I would want for this. So I'm going to use that, but the MFM read command followed by the different parameters is how you would normally read one of these. Now I'm going to go ahead and make a new directory for this. So Nightmare 5160, because this is the drive from that. Go ahead and change into there. And then I can run full read, because I put it in my user's bin folder. And with that, we'll be able to read the hard drive. All right, with the drive read done, we can see in that directory, we now have the 3 files that I told it to create. The data file is, I mean, it's exactly what you would want it to be. It is the DOS partition that contains all of the data laid out. We'll use that with 86box here in a moment, and we'll be able to boot that hard drive in a virtual machine, which is super cool, but you could also extract the files out of there if you really wanted to. The emu file is specific to this device, and that's what we'll use later to remount this drive as a virtual drive using the MFM emulator. And then the transitions file is the raw flux data. That's really only useful on this device itself because I don't think there's anything else that works with it. But yeah, that is what that is. So if you want to get the lowest level copy of the drive, you need to save the transitions file as well. Now, we were able to successfully image the data, and we can see that we got the files and checked what they were, but these files are on the BeagleBone Black right now. It has a built-in flash chip that gives it some internal storage. Now, there is an SD card slot. You could use that and save the data from the drive reads to that instead, and then pull that out and put it in your other computer. Or we can use the fact that this is a whole Linux machine to our advantage, and we can just pull files off of it over the network. So I'm going to go ahead and do that now. So I have a couple of other reads that I've done here for practice, but we're going to go ahead and pull off the one that we just did. So I'm going to use the program SCP, and I'm going to do a recursive copy. So we're going to pull out the folder that is Nightmare 5160, and we're going to store it here, which is going to go into this directory that I have there. So go ahead and grab all of those files. All right, and there we have our files copied. So we can see here going into the folder, there is everything we need. So I'm going to go ahead and copy this file. I'm going to call it the Nightmare 5160 underscore HDD.img. I'm going to move this to my 8088 already configured 86box instance here. I'm going to put that file in there, and then I'm going to launch 86box. And I'm going to configure it to use that hard disk image. So I'm leaving this as an IDE setup here. It doesn't really matter because it's just the raw data of the partition. So being IDE or MFM in 86 box, which emulates different kinds of hardware, it's not really going to matter. But we can get that set up. This is the file we just pulled off the BeagleBone here, and we're going to go ahead and boot it. All right, here it is, booting our disk image of the Nightmare 5160 system. So this should go through, it'll add like the, what was it, Norton antivirus and stuff. But yeah, this is exactly what we saw when we booted that computer. And there it is. We imaged the hard drive and we're able to emulate it on a modern system. That is so powerful and awesome to be able to do that. I have not had a way of doing that with MFM drives. So this, to me, just fills a hole. It suits a niche. It's so nice to just be able to finally know that this is possible. So yeah, from here, we could do all manner of things. We can see the version of the operating system that's on there. We can launch, edit. It's gonna be slow because this had DOS 622 on it for some reason, which can run on an 8088, but it's not fast. But it's totally working and we can access the files. So now we're done imaging this drive. You might be able to get away with hot plugging it. I'm not gonna do that. So I'm gonna go ahead and sudo power off the BeagleBone. That way I can know that it is shut down because it is a modern Linux computer. It's better to let it gracefully shut down. But after the BeagleBone is shut down, we can power it all off and then we can disconnect this drive. And we'll go ahead and make an attempt at imaging this drive, but again, it's not gonna turn out great. All right, so now I'm going to swap in the ST412. So get this one out of here, pop this one in. And again, for provenance, this is the drive that came with my IBM 5160. I have copied the files themselves off of this before, putting an XT IDE in the same system as this. By the way, I tried to do that with this drive, but the controller for the ST225 is in the same address space as the XT IDE is by default, and you have to change the ROM on that MFM controller to change which address it runs at. And to change the XT IDE, you have to get the XT IDE config tool on it and then run that on the machine itself. And the last time I was trying to do that, I didn't have a good way to do that because I just brought the XT IDE with me to the person's house who owns that computer. And I was like, let's copy the files. And then I couldn't. So yeah, that's part of why we're doing this. Just get it totally done with it all out of the machine. Makes it way easier. But now we'll get this drive connected and we'll see what limited stuff we can do with it for now. All right, let's get this drive fired up so that we can see what we can do with it now. All right, I'm into the BeagleBone. I'm gonna go ahead and make a new drive again for this one, ST412. Let's change into that. And we're gonna use my same full read script again here, although this isn't quite going to work right, but we'll just do this for now so you can see what happens. Okay, now let's talk about what is weird with this drive. This ST412 is the original drive from my IBM 5160 that I got years ago. It is an early example of an MFM drive, and the controller card it was used with was 2. It was also very strange. MFM drives are controlled almost identically to floppy drives. There are signals to step the cylinders, change direction, and read the data that passes under the head. This gave MFM hard drive controllers direct access to the magnetic data on the platter. Later interfaces like IDE and SATA would abstract this away. But because it was up to the controllers to handle the drives directly, there was no one standard way to map the data on the platters. Different controllers can specify different sector IDs or have slightly different timings. This is why you can't just move an MFM drive from one controller to another to read it. Now, the MFM reader hardware can account for this, but it can only work by being programmed with known examples of data from different drives that were handled by different controllers. And this brings me to my drive. My ST412 was controlled by an early XBEC card. This card has a very unconventional way of laying out the sector IDs that requires a skew be applied to their values to order the data correctly. My particular drive, though, also has bad sectors that were known and mapped around. So all of the data is there, but the sector IDs have ended up different, and any data after the bad sectors has a different ID skew.
When I initially read and decoded my drive, the data was bad and it wouldn't boot. I got some wonderful help from Ben and Tommy that indicated the skew changed. The software for the MFM reader didn't account for this weird skew to change in the middle of the drive. I emailed David Guestwin, who created this device, with a sample of my Flux transitions file, and he was able to update the software to account for this. The XSpec skew is now recalculated per cylinder to account for this kind of issue. Now, the XSpec handling is one of the newest features of this, so I want to give him a huge shout out and thank you for that, because this is an edge case of an edge case, and he solved it lightning fast. With all that figured out, I can now redecode my transitions image using MFM util, which you can compile on x86 systems, by the way. I still get the bad sector warnings as expected, but now the decoded image is valid and can be booted in 86box. This is a very good example of a reason to save the transitions file when reading a drive. You can always reprocess it later with MFM util, and if you run into a new edge case yourself, it will be needed to debug. With that solved now though, we can go back to what I previously filmed to see one more thing you can do with the data image.
All right, now before we move on to trying to emulate using the emu file, a whole hard disk in another old PC, I would like to take a look at how you can get the files off of the data file that you can get from this. So just as an example on Linux here, I have this script that I've written, and I've used this kind of a lot. This is going to mount the image file that I created within Linux in a way where I can then get into the file and copy files out of the disk image. So let's go ahead and try that with the Nightmare 5160 image. So I'm just going to run mount image with this. It will ask me where the partition starts, and I'm glad I did that because apparently this one starts at 17 sectors in. That's a little weird. Usually it's 63. And with it mounted, after I remembered my password, we can get into the drive right there, and that is not everything. Okay, one thing I was not accounting for is drive space. So yeah, that's not going to work. So 86box would be the best bet of getting files out of this, because yeah, we need to have DOS unpack all of the data. Now we know why they're using DOS 622, because they didn't want to get a bigger hard drive and they wanted to fill it full of garbage. Okay. So in less dumb circumstances, this would have worked, but in this case, yeah, all of the files are now in this, which is a whole other problem to try and work out. But normally, yeah, this should work. Okay, next, I want to try emulating the ST225 drive with the MFM emulator, and we're going to configure it to use the emulation file that we just made of that drive, and we're going to configure the Linux system on here to automatically start up with that emulation. Now, you can start it on the fly, but that would be a little weird, so using the config file to set your emulation file so that it will automatically start that on boot is going to make a lot more sense in the long run. So let's look at how we can do that. So included in the image for the BeagleBone here, which again, my unit came from Decromancer, so all of this was set up, but you can find some of the stuff in the Git repo for the main software. It is set up so that there is a config file for defining your emulated drives. Now, we are going to need root permissions for this, so we'll need to use sudo. Looks like we're already in the sudoers file, so that doesn't require a password once you're logged in. And this line here is what we need to change to point it to the file that we just created from our drive. So I'm going to get rid of that, and I'm just going to type in the path, which is nightmare 5160 underscore emu, not underscore there, it's underscore here, emu underscore file, and I believe that might be all we need. I am not 100% sure what the backup stuff is there, but we definitely want the power off command, and we're going to have to take a look at one more thing related to that. But I believe everything else there looks good, so we'll save that file, and then we will use system control, which is a systemd thing. That allows us to enable the MFM service, and that will have set it up so the next time the BeagleBone boots, it will be emulating an MFM drive on the card edge connectors so that we can access the drive on a computer. So we're almost ready to do that, but we're going to power it off and then take a look at one more thing we need to do to make this work a little more smoothly. So on the hardware here, there is one thing that we want to change before we start using this as an emulator, and it is this jumper. We want to put it on the right side here. What this does is it brings this capacitor, which is actually a super cap, and you know what's so super about it? Well, it's 2.7 volts at 10 farads. That's nuts. So that thing holds a just ridiculous amount of power, and it acts as a graceful shutdown UPS for the BeagleBone. So when power starts to get low voltage going into this thing, it will run that power fail command, and then it will shut down the system once you flip the switch on the power supply of the PC that it's in, because that will cut power into this. And normally, yeah, it's a bad idea to shut this down non-gracefully. So yeah, that's a really nice little feature built into this thing. One of the reasons why this is just a lot more complicated than other things, but that jumper there will activate the power fail option. So that is required for this. But other than that, I think we're ready to go. All right, let's get the device in here. So again, this can fit in place of a hard drive in the system with this handy little 3D printed bracket, which is pretty darn cool. Let me grab a screw and get that cinched in place so it doesn't slide around and bump anything it shouldn't. There we are. I'm just going to put one in for right now because this is not a permanent installation. Then we'll go ahead and connect the card edge connectors here. And then finally, the power cable right there. That's it. Let me put this blinking plate back in here, and then I'll slide the case back on, and we'll fire this thing up and see how this works. And there we are. That fits in there quite nicely. The layer lines on the 3D printed case are catching the light a little oddly. This angle looks a little more realistic here. But yeah, with that, you'll be able to configure the emulator from the front without removing it if you want. And I think that's a pretty nice feature there. All right, there are all the peripherals we need to test out the machine. The drive is in and this drive is out. I think we're ready to try it. So let's see what happens. It does take a while. Beep. Should access the drive. Starting MS-DOS. And there we are. We are booted into the DOS 622 install from this hard drive on the MFM emulator. That is so cool. That is not a feature that I would have initially thought to put in here, but that is so awesome. Yeah, there are all the files. That is working fantastically. All right, now just to prove that it works, I happen to know that on this drive there is a typing tutor program, so we can run something that is being hosted on the drive. There we go. Now we can see the BeagleBone blinking an LED down there. And we can see the drive access LED. It's kind of difficult to see, but it is absolutely working down in there as we do stuff. So this is, this is really, really cool. Well, I think that's almost every single feature tested on this board totally working. There is one more thing we need to do, and that is the graceful shutdown power failure.
Testing the power off feature ended up being tricky because the Linux system shuts down very fast with no logging. On the device, the supercap is used to power a 5-volt regulator that the BeagleBone runs off of. As my best guess means of attempting to check if the power fail is working, I was able to measure the supply voltage after removing power. The lights on the SBC all shut off well before the 5-volt rail starts to drop, so it clearly has plenty of time to finish before shutting down. This is critical for using it as a drive emulator, since the host system will just cut power, and if the Linux system isn't ready, it could corrupt files. Externally powering it while using it as a hard drive would be the only other option. So the power fail here is much more elegant, even if it feels a little odd.
Well, there we have it. That is the MFM emulator by David Gueswin. That is a fantastic tool. Man, yeah, being able to emulate drives, that is crazy helpful. I could totally see having multiple of these for really weird systems where it's just difficult to get good hard drives for. So yeah, That is excellent, and I'm really impressed. That is definitely going to be something that I have at the ready for any time I encounter MFM drives from here on out. But that's going to be it for now. If you enjoyed this video, you may want to subscribe to be notified when I release another one. If you want to help support the channel, you can find me on Patreon. But that's it for now, and I will see you next time.